Hi everyone, welcome to my YouTube channel, and in this video we will talk about problem 15 from Leetcode. So this is the problem where we will be using 2 pointers to solve this problem. So let's look at the problem statement, and here is our problem statement, and let's look at my solution together. The first approach is, we will be running for loop 3 times. So that's what we call the naive approach. And if you can see here, so we have 3 for loops going on, and then the range is from, so in this case the initial guy, so this first our first for loop is denoted by this blue color. And notice that we don't have, like typically we have length of nums, but in this case we have length of nums minus 2. That means our s will be going from here, that will be the 0 index, from here all the way to here. So that corresponds to length of nums minus 2. And then we will be running another for loop here, that's the inner for loop, and we have our indexes from s plus 1, so this guy plus 1, so it always starts like the one number after this, so from here all the way to length of nums minus 1. So notice that we have a minus 1 here, and then we run another for loop, so for k in range of j plus 1, so like here, and then we'll be running all the way to the length of nums, like n position. And then we will be checking, like when we get a match, meaning that when nums of s, nums of j, nums of k, they sum to 0, we have to check that whether this is a redundant triplet. If this is a redundant triplet, then we don't append this to our result. So this is, as you can see, we run this for loop 3 times, so we get time complexity of n cubed. This is really not good. So how should we improve from this? Notice that here we are not asked to provide the location. Like we don't have to provide the index location. We just have to give the numbers, right? The value of these numbers. So that means we can make a change to our input array. So that should be like, we can maybe sort this array first, and then we can apply 2 pointers, right? So that's the improvement from this one, and there will be this guy. So we have 2 pointers. Actually in this case we have we can say 3 pointers, I think, because this blue guy, so blue guy can be, it's also a pointer, right? It's also, we are iterating this blue guy from here all the way to the end. So we have this left pointer, right pointer. So first let's use the one example given in this problem. We have nums array, we have -1, 0, 1, 2, -1, and -4. Now we sort this. Now we sort this array, and sorting in Python takes O of n log n. N is the length of these nums. So that will be -4, -1, -1, 0, 1, and 2. And then we will be running, we have, so our first pointer will be this guy, this blue one. And then for a fixed pointer, like for a fixed location, we have 2 pointers, left pointer and right pointer. And then we will be either incrementing left pointer by 1 or decrementing this pointer by 1, or when we get a match, we increment left pointer by 1 and decrement right pointer by 1, like at the same time. If you look at here, this is the code that I wrote initially. Like this one should be 2, actually, right? This one should be 2. So this is on base case. If the nums array, if we are given, say, like an array with 2 numbers, then we just return empty array. So this one should be 2. Now we sort this array. Actually you can just have, you can just apply nums dot sort without doing this, and then we have our result array. So this is an empty array. Then we have a for loop here. This I corresponds to this guy for s in range length of nums. And then we have a left pointer that's here is given by low, and then we have high that's given by length of nums minus 1. then the target is just negative of nums of I. All right, and then we have this, we have to run this, our 2 pointers here. We run this while loop until our left pointer is bigger than the right pointer. I mean, it's higher than the right pointer. Then we check if the target, if the sum of those 2 pointers is less than the target, that means we can increment low pointer by 1, left pointer by 1, and then otherwise we decrement right pointer by 1. If we get a match, then we check if this triplet is in our result. If this is not in our result, then we append this, and then we have this one. We increment left pointer by 1, decrement right pointer by 1 at the same time. But this one is what we have time complexity of n log n. That's from the sorting, and then we are running this for loop, so we have n, and then we have another this while loop here going on, so we have n square. So we have O of n log n plus O of n square. We get O and n squared in for time complexity. This one, if you run this code, I think this one should work. Like when I tried this problem like about a year ago, this one worked, but when I try this again, this one didn't work because, well, this O n squared, that's the worst case time complexity, but we can still make an improvement from this. What about if we have something like this, right? We have -1, -1, -1, -1, and 4 zeros and 4 ones, right? And in this case, the answer should be just -1, 0, and 1, right? Now that's the only triplet that we can add to our result array. But when you run this code, I think this one is very inefficient. So how should we make an improvement from this? Notice that here, if you look at the first for loop, so we are iterating this from 1 by 1. Instead of doing that, if we get a redundant numbers that comes after this initial this one, say for instance we see that we have all these redundant numbers coming in, then why don't we just shift our green pointers, like these green pointers, to the right. So that's the key idea behind this. And so basically we will be doing something like this. If our current position is bigger than 0, so we are at the least we are starting from the first, like this second position, and then we compare if this guy and this guy, if they are the same, we just keep moving to the right until we don't get a match. So that's what's going on here. And then once you do that, we also have to make some change to this left pointer and then the right pointer. If you look at here, well, so we notice that all these numbers, like these 3 circles, have all values of 0, which is identical to where our left pointer is pointing at. And then we have 3 ones, and then this is also 1 where right pointer is pointing at. So if we can somehow move this left pointer all the way to here and then the right pointer to here, that means we can make significant improvement from my previous approach. Like the worst case time complexity is still the same. If we get a distinct numbers, then doesn't really matter. But in this case, when we have three same numbers, like I don't know, like 100,000 of them, then this approach will be much faster. So let's look at that code, and that's this code. So the tricky part is this part. So if index is greater than 0 and nums of index is equal to previous one, not the +1. If we have a +1, we don't get all the answers, right? It will miss some like triplet. And if we don't put index is greater than 0, then we have an issue with this guy. So that's something that like there's no shortcut for coming up with this part. You just have to try case by case, and then at least that's how I did it. And then this part is still the same. Like here, the only difference is that we'll be checking if the numbers that come after the left pointer, if they are the same, then we move the left pointer, keep to the right, until we do not get the same numbers. We do the same thing for the right pointer, and then yeah, that's pretty much it. So let's look at the code and see what we get. Here is the code that I just showed you on my PowerPoint slide, and let's run this. Yeah, okay, so that's for this problem, and I hope my video helps you guys understanding this. If my video helps, please subscribe to my channel, and I will see you next time. Bye bye.